Why are the street lights still switched on even in the morning? The civil authorities always forgets to switch it off. Can we find some way to switch it off automatically in the morning?
Hi friends, do you want to take up this challenge and solve my friend's problem? Yes? Then let's dive into the magical world of sensors and explore how we can solve this problem. Let us find out which sensor can solve our problem. No, not this one also. Yes, LDR sensor can solve our problem. Let me explain to you what LDR sensor is and how it works. LDR stands for Light Dependent Resistor. And as the name suggests, it's a type of resistor that responds to changes in light intensity. Let's understand how the LDR sensor works. The LDR sensor consists of a semiconductor material that exhibits a property called photoconductivity. What is photoconductivity? Let's understand it. We'll break the term photoconductivity into photo and conductivity. What does photo stands for? Photo means light, and conductivity is a property of the material which decides how much electricity can pass through it. The conductivity of the LDR sensor depends on the amount of light falling on it. If more light is falling on it, then the conductivity of the LDR sensor is higher or the conductivity increases, which means more electricity is allowed to pass through it. If the light falling on it is low, then the conductivity decreases and thus the amount of electricity passing through it also decreases. In other words, the conductivity of the LDR sensor depends on the intensity of light falling on it. So now that we've understood about the term conductivity, let's understand about another term known as resistance or resistivity. Resistivity or resistance is a reciprocal of conductance or conductivity. Higher the conductance, lesser is the resistance. We have learned earlier that LDR stands for Light Dependent Resistor, right? So this is where we bring in the term resistance. If the light falling on the sensor is high, the resistance will be low, and if the light falling on it is low, then the resistance will be high. This can be understood by this picture here. When the light falling on the LDR sensor is low, then its resistance is 9000 ohms. But when the light is falling on the LDR sensor, then its resistance decreases and it goes down to 400 ohms. So now we understand that the resistance values of the sensor changes as the intensity of light changes. The next question which arises is how the LDR sensor measures the intensity of light. We have learned that as the intensity of the light changes, the amount of resistance of the LDR sensor also changes. This change of resistance is converted into an electrical signal. And through this electrical signal, we are able to measure the intensity of the light falling on it. Thus, we can say that the LDR sensor measures the intensity of light falling on it by converting the resistance into an electrical signal. Now that we are able to measure the intensity of light in the surroundings, we can use it to create a smart light for us, which will automatically turn on when the light in the surroundings is low. Let's start creating our project. The things that we're going to need for our project are an Arduino Uno board, a breadboard, a LDR sensor, an LED, two 330 ohm resistors, and jumper wires. Let's join the components now. First, connect a jumper wire from the positive rail of the breadboard to the 5V pin on the Arduino. This provides power to our circuit. Next, connect the GND or the ground pin of the Arduino to the negative rail of the breadboard. This ensures common ground for all our components. Now I will place the LDR sensor on the breadboard and connect any one leg of the LDR sensor to the positive rail of the breadboard. This provides power to the sensor. Note that LDR is a kind of a resistor, so it does not have any positive or negative terminal. We can use any one as positive and the other one as negative. Now I will connect the other leg of the LDR sensor to the negative rail of the breadboard using a 330 ohm resistor. This completes the ground connection for the sensor. Next, connect the output wire from the same leg where the negative of the LDR is connected to the A0 analog pin on the Arduino. This is how the sensor sends data to the Arduino. Now take an LED and place it on the breadboard near the LDR sensor. Connect the negative end or the shorter leg of the LED to one end of the resistor like this. Connect the other end of the resistor to the negative rail of the breadboard. Finally, connect the positive leg or the longer leg of the LED to pin number 12 on the Arduino. This is where the LED gets controlled by the Arduino. This completes the circuit for our LED. With the hardware setup done, it's time to write the code for our smart light. For that, I will connect the Arduino board to my computer using a USB A to B cable. Open the Arduino IDE on your computer and create a new sketch. First, we'll declare all the variables that we'll be using in our code. We start by declaring a constant integer named LED and assign it the value 12. For that, we'll type in the code const int LED is equal to 12. This tells the Arduino that pin 12 will be used to control the LED. Next, we declare another constant integer named LDR Sensor and assign it the value A0. For that, we'll type in the code const int LDR Sensor is A0. This tells the Arduino that pin A0 will receive the data from the LDR sensor. Next, we declare an integer variable named as state. So I'll type in the code in state. We'll be using it later on in our code. After this, we'll declare an integer variable named threshold and assign it the value 200. So for that, I'm going to type in the code integer int threshold is equal to 200. This threshold value will determine when the LED turns on or off based on the light intensity that we are going to receive from the LDR sensor. If the intensity received from our sensor is less than 200, we'll switch on our LED, and if the value received is higher than 200, we will turn off the LED. We will learn about this in the later sections. Next, we initialize the setup function which runs only once when the Arduino board powers up. This is the setup function that I'm talking about. Inside this function, we declare the pins that we are going to use as inputs or outputs. We set the LED pin as an output pin and LDR sensor pin as an input pin. So for that, we'll type in the code pin mode, and I would set LED as the output pin, and I will again type pin mode, and I would set the LDR sensor as the input pin. I would also write the code serial.begin 9600. So by writing this code, we are starting the serial communication at a baud rate of 9600. We do this so that our Arduino board can start communicating with our computer and we see the output of our sensor on the computer screen. Next, we start the main loop of our program, which is this void loop. Inside this loop, we read the analog value from the LDR sensor and store it in a variable called as state that we have defined earlier. So now we would use this state variable and we would say that the state is equal to the analog value that we are going to read from the LDR sensor pin. Next, we would check if the value of the state or the value that we are getting from the LDR sensor is less than the threshold value or not. If the value that we are getting from the LDR sensor is less than the threshold value, we would turn on the LED by setting the LED pin to high. That means if the surrounding light is low, we would want our smart light to be on, right? So for that, we will type in the code if the state value, which is the LDR sensor value that we are getting from the sensor, if this value is less than the threshold, which is 200 that we have defined earlier here, if the state value is less than the threshold, we would want that our LED should be glowing. So I will type in digital right LED should be in a high state. High state means it is going to be glowing. Next, I would want the values that I am getting from the LDR sensor to be visible on my computer screen. So for that, I would write in the code serial.println, and I would want the values of the LDR sensor pin, which is stored in the state variable, to be visible in my computer screen continuously. And I would also want that this keeps refreshing every 2 seconds. So I'm going to introduce a delay of 2 seconds here, which is I'm typing in as delay 2000. 2000 means 2000 milliseconds. Now we have defined the case where the state value is less than threshold. The other case is the state value or the LDR sensor value, which means the light intensity. If it is greater than the threshold, we would want our LED to be switched off. So for that, I will type in the code, else we would want the LED to be switched off. This means this defines the case that the state value is greater than the threshold now. So in this case, we would want the LED to be switched off. That is, we are defining that by typing in that LED should be in a low state. And again, we would want the values to be continuously visible on my computer screen. So I'll type in the code serial.println, and I would want the state variable, the values of my LDR sensor to be visible on my screen, and I would introduce a delay of 2 seconds here as well. So now that our code is done, we would check if the board that we have selected is Arduino Uno and the port that we have selected is a USB modem port or not. So with all the things good here, we would now verify or compile the code and check if the code that we have written is correct or not. So yes, the code that we have written is absolutely correct. So let's upload the code and see if it is working or not. At present, there is ample amount of light in the room. So the LED is switched off. If we cover the sensor, that is, if there is low light around the sensor, the LED automatically starts glowing. This shows that our smart light is working.